Okay, hello, good afternoon. This is Junichiro Horikawa, and this is the 99th episode for Houdini Algorithmic live stream, which is a weekly tutorial live for Houdini. And this is 99th episode, and the theme for today is to create a fiber structures like these, which is currently applied on top of a bowl shape using tons of fibers to wrap the geometry like these. And yeah, I would like to try to create this kind of structures in Houdini from scratch. Okay, and there is a place that I got inspired from actually in order to create this, which is from this website. It's a forum page for a rhinoceros and grasshopper, and one guy is showing how he can create this kind of interesting structural shape using triangular mesh together with those line networks and twist it from the center of the connections of the triangles to create these network. So I'm following the steps that he has explained in this page in Houdini. Now in this case he's using Grasshopper as a medium, but for myself I'm going to use a Houdini to try to mimic this effect. And because I'm using Houdini, I am going to try on different kinds of mesh geometry later, as well as applying some animation to it. Could be interesting, right? So the initial thought, I thought this structure is pretty interesting, so that's my initial feeling about this thing. Right, so hopefully this will be interesting for you guys as well. Now, there is one thing that I want to promote in terms of the activity that I'm doing right now. Recently, me and a graphic designer called Hiromasa Fukaji in Japan, is going to hold a exhibition in Tokyo from July 9th to July 19th in Shibuya, Tokyo, and the exhibition is going to be held in Shibuya Hikarie 8, which is a building close to the Shibuya station at the 8th floor. We're gonna hold the graphics exhibitions using a nature simulations as a theme and plot it onto a paper using a pen plotter by this graphic designer who is working on a lot of pen plotter projects inside Japan, which is going to be really, I think it's going to be really cool. We're going to have several numbers of graphics being displayed in the exhibition, so if you happen to be in Tokyo during these days, please try visit. Right, it's totally free to come, and so I hope you have a chance to visit. Right. Well, we're also going to create some catalogs, so hopefully we'll be able to sell it overseas as well. Hopefully. All right. So let's try to create this from scratch. Now, before get it into the detail, let's try to sketch the method. How are we going to deal with this? Okay, so first of all, as the page says, we are going to first of all create some triangular network, which is pretty simple to do in Houdini. You just need to remesh one of the given mesh, right? Then the next thing you would do is to create a triangular network like these. Okay, so for each triangle, you pick up the center point or centroid point, then create a flower-like network shape. So pick a center point and create this kind of network for each center, for each triangle. Right? Then what I'm gonna do next is to, let's just draw this one. What I'm gonna do next is to pick the vertices on a triangle, and from these vertices, what I'm gonna do is to apply some vector rotations to the clockwise or counterclockwise direction, meaning I'm gonna apply some twisting deformations up to these areas. So for this vertices, I'm going to pick up these dual mesh part and rotate these curves in this clockwise direction. And as a result, what you get is something like this. And you do the same for all the other dual mesh part. Rotate, rotate, rotate. And as a result, what you get is something similar to these. Now, for these things, it is rotating in both directions, clockwise and counterclockwise. And so by adding those two lines together, you get this kind of a flower-like effect. So that's what I am going to try to do, and probably by creating these network like this, by opening the center a little bit, you could create it as a column as well. Maybe we could also try that. Okay, that's the goal. That's the process that I'm gonna try out, and let's see how we could do this from scratch. All right. Let me just bring this. Hello, everybody. Thanks for joining. Hopefully you have a good day. Okay, now, first of all, I'm going to set the background to dark and save the file to today's folder. Oops, not this one. Fiverr. Alright, so let's start with a really simple like mesh like sphere. So let's give a sphere as an initial geometry, which we want to change it later to something different to see if the same system could be used for any geometry. Right, so let's change this to polygon, and let's also create a switch so that later we want to switch the geometry to something different. For now, I'm gonna go with this one. Now, I am going to make this frequency of the sphere a little bit higher than initial geometry. Then what I'm gonna do next is to, first of all, apply a normal attribute to a point, which I'm gonna use it later, like these one. And then And what I'm going to do is since the number of triangles is a bit too much right now, so I'm going to try to reduce it using remesh. I mean, you could directly use this sphere with low number of triangles like these. Maybe I could try with that first. And in terms of the remesh, I could go back for a custom geometry, probably. So let's get it here. Okay, so let's try with these number of triangles. A low number of triangles as possible for a sphere. Okay, and first thing first, what I am going to do is to create this kind of network on top of the triangle shape. I mean, any way is fine to do that. The way that I'm gonna do is to, as always, for myself, I'm gonna use Vex to create a curve drawing on top of the sphere. I mean, on top of each triangle. So in order to draw on each triangles, I'm going to pick each triangles using primitive wrangle. And let's draw lines. Okay. So first thing first, for each triangle, in order to create the drawings or lines on top of it, like what we see, we need to know the point positions for each triangle vertices as well as the center point. So let's get that. First of all, the center point is at P, the centroid of the primitive. And let's also get all the point numbers from the primitive using prim points. Right, then let's loop through the point numbers. If we have 3 points, then we're going to loop 3 times. Let me check if we have 3 points from this prim points in order to check if the number of loops is correct. Okay, let's check the geometry spreadsheet to the primitive, and yeah, for every triangles we have 3, so I think it's correct. We have 3 points being picked up from the PTS prim points, meaning we are going to loop 3 times. We're going to create 3 iterations for the loop. Alright, so first thing first, let's try to draw one single curve like this. And in order to rotate the lines from each vertices of the triangles, as I said, like this, in order to pick up the dual mesh out of each points, it will be a good idea to separate this line and the line connects us from this vertices. So each lines created from each vertices will be just a single line, meaning you have only 2 points for each lines. Okay, so let's try to do that. So meaning that for each vertices, I am going to just create a single line from this point to the center, this point to the center, this point to the center. So in order to do that, what you need to do is to say, first of all, add a new point to the center, which in this case you can call this PT probably, and add point to the center positions. Okay, and do we have it? Yeah, right here. It's a bit hard to see, but there's a point being created. The next thing, what I want to do is to pick the point number out of this loop, which is going to be the vertex number, and then I could start drawing a line. Okay, so the line is equal to at prim 0 poly line send pt and pt. Okay, now it's a bit hard to see now. Let's change this to a wireframe or something. Alright, so there you go. You have a single lines being created for each vertices. Now, I could go with this direction. For each vertices, I want to have the curve created. Let's look at this way. I want to create the lines for each vertices. I want to create lines in this direction and also in this direction as well, right? For this point, you want to create this point from this direction and this direction and this as well. Okay, now looking at the original geometry like this one, or probably somewhere around here, or maybe this one, you see that there are no connections on the center on the connection where it's supposed to be the vertex point position of the triangle, which is right here, or maybe the center point of the triangle. Yeah, probably this is the center point of the triangle. This you could see small triangles underneath this image. Okay, this is a triangle that we're trying to create, and on the center point there are no line connections to this one, and I do like the image of this one, so, and actually I don't really want to create the lines on the middle, but just want to create the curves on the side except of the middle. So to prevent having the lines on the center, I am going to go without using the center point positions as it is, but kind of a lerp from the center to the side, meaning if I have a triangle like this and here's the center point positions, what I would like to create as a result is something like this. Avoid going through this center point. Okay, and in order to create that, what I could think of in terms of the process is, first of all, project this center point to the midpoint of the triangle, like that. And for each vertices, you could estimate the curve positions for the right side and the left side. Now, this line is going to be on the right side, and these lines are going to be on the left side, and each one is using the different middle point, right? And in order to create these lines, what you need is the point on this vertex and also the point position of these edges. And these position P could be calculated using the center point position and the projected center point position by using something like lerp between C and PC with some factor value. Okay, if If the factor value is 0.5, then you get the middle point position. If it's 0.2, then 20% from C, somewhere around here. 0.8, 80% from C to PC. Okay, so that's what I'm going to use in order to get those point positions and try in order to create these lines. All right, so let's do that. And in order to do that, you need to know how many lines you want to create on the side, on the left side and the right side. In this case, I'm creating 3 on both sides, but that could be as a variable. That could be a variable you could change. So let's give some parameter in order to control that number. Okay, let's start with something small like 3. And in order to create that, I'm going to create another loop inside the loop until the number. Alright, now the vertex point number is PT, and what I need is the point position for these 2 sides. Now since we have 2 sides, I think it might be a good idea to have another loop, which is becoming a bit complex, but let's do it. And in these cases, we have right side, and let's just try with the right side hand, and let's see how we could expand it to the left side later. Okay, so if we are just looking at the right side of this vertices or this triangle, what we need to know is the center point position of this edge. Alright, so in order to get that, you do need to know the neighbor point position from this point number. Now how do we get that? Actually, we could get that information from this PTS, right? So if this is the PT1, then this is PT2, this PT3. So let's say the current point number is PTSI, and the next point number is PT2, which is actually PTSI plus 1. Now there is possibility that this number goes over the length of this array, so let's give a modulus remain calculations so that it will reset to 0 if it goes over the length of the size of the array, right? So now that you have the PT1 and PT2, or maybe this one, I'm not sure which one is going to be picked up, left side or right side, and what I want to get now is the center point positions in between these PT1 and PT2. In order to do that, we do need to know the point positions of this point and this point. So let's get that by using point function at PT1, point position at PT2, and get the middle point position by adding 2 points together multiplied by 0.5. Right. Okay, now that I got this point positions, which is on the middle of this edge, it's time to lerp the point between the center point of the triangle and center point of the edge. And we'll do that inside this loop. So new point positions 1, 2 is equal to lerp between the center point and the midpoint position. and we're going to provide some functional value which is in between 0 to 1. We don't want to use 0 because if we set 0, then what we get is the connection from the vertex to the center. So we want to create some offset from the center a little bit. So let's create that value by adding 0.5 to the n, then divide it by the whole number of the loop. As a result, you get a value in between 0 to 1, but never goes to 0 or 1, but slightly offset it. Okay, then now that I have this point position created, let's add a new point to that point position. New pt12, add point, new pos12. Alright, so I have now a bunch of points being created. What I want to do next is to connect these points with the vertices pt1. So let's do that. Line 12 is equal to add prim 0 polyline pt1 and new pt1 12. Alright, so seems like I have just created the right side of the triangle with these lines. Now let's also remove the original geometry because it's a bit confusing to see those. Okay, so if we look at the original triangle, looked like, let me show up the shaded view with the edges. So originally the triangle looked like this. Now by using this triangle, okay, so I have created the left side of the edges from this vertices. You see the left half of the part until this middle point has been created, like these lines. Now what I want to do is to do the same things for the right side part. Okay, so in order to do that, what I need is to set this pt2 being used for this side. In this case, if I just add 2 to this one, you get the right side. Okay, so when the addition is equal to 1, then you get the left side. When the addition is equal to 2, you get the right side. So what you need is an additional for loop somewhere around here. And maybe you could start t from 1 until 2. Like this, and just replace this one with 2. I mean t. There you go. Okay, simple as that. Now you have created a bunch of lines from each vertices, like this. Now, what I want to do next is to set some groups or set some attributes to each of the each of the lines that I've created, to let it know which lines belongs to which vertices, so that it will be easier to do the rotation later from each vertices to the dual mesh part. So let's do that. First of all, I'm going to apply some primitive group to the every lines that I've created. Set prim group to the line. Gotta name it. So I should say line, I don't know, and prim num 1. Okay, hello. Sarhat Kam, which language is this? This is Vex. The language itself is called Vex, which is inspired or inspired by, based on the language, C language. Not really a C++, but just a C. So you cannot actually use a class or anything. It's pretty basic language. Not much things you could do in which you found in rich programming languages, but is enough for vector operations or linear vector operations or matrix operations. Okay, let's also apply some primitive attribute to know which lines belongs to which points. So I'm gonna create the attribute called ptnum to each primitive and derived from pt1. Okay. All right. Anything else? Anything else? I think for now, I think it is fine with this. To go to the next step, we might gonna go back and add some stuff, but for now, let's go with this one. Okay, so now that I have created the lines, in order to rotate or deform this geometry by rotating these lines in this directions or this rotation disorder, you do need to have a bunch of points to each lines. Right now you have only 2 points connecting 1 point in order to create these lines, but if you just have 2 points, then it's not possible to deform the geometry. So what I'm gonna do is to add several points to each lines, and then we'll be able to rotate it. So to do that, first thing first, I am going to merge all the duplicated point positions using fuse, just in case. Just in case, yeah, probably I would need this. Okay, now I am going to use a resample node to add a bunch of points in between the lines. Now these things could be controlled right here, or yeah, something like that. And probably it's good time to add a new node in order to store all the parameters that I want to control later, which I always do. So one of the parameters that I want to control is the shape input. Currently I only have one shape, so this is going to be 0 initially. Another value is this number of lines here, and another value is this resample length. I'm just gonna call resolution, probably from 0 to 0.1 for this kind of a size. Oops. All right. So let's see if this works. Okay, I can control the resolutions, I can control the number of lines from each vertices. This is already nice. And the shape, right now I only have 0. I mean this one, so 0 only works. Now let's try with 3 with the low number and raise this up later. And let's also check the number of points, how many points we need. I don't know. Let's try with 0.02. Now that I have this information, next thing that I want to do is to actually smooth this out a little bit, actually, in order to make this part a little bit smooth. Now, since I have created those lines separately, it's a bit hard to create a smooth shape connecting these lines, different lines together. If you just use something like smooth, it wouldn't smooth the corner as I want. Or if you use a attribute blur, it doesn't also do what I really want to have. Just disconnect. I mean, I might need to fuse this again. Now this might be okay. Not sure. Maybe this is fine. But as you can see, you don't get really smoothen out even if you increase the blur iterations. It only look at the very neighbors. Maybe if I change this proximity, change the radius, and increase the ratio, well, didn't really work. So instead of using attribute blur or smooth functions, a smooth curve, what I'm going to do is to, and what I'm going to test out is to, first of all, try to create a single polyline connecting these two connected lines. Then in those cases, you can use the smooth node to smooth this singly connected polyline. So let's see if we could do that. First of all, I'm going to try with using polypath to those connected lines and see if you have, if this has created the connected curve. And seems like it did, like that. Okay, looks good. Now, for those connected lines or polylines, you could use smooth node in order to smoothen out the edge. And more iterations you have, more strengths you have, smoother edge you get. That's good. Now, the problem is what I want to have as a structure is actually a two separated lines. But right now, I have connected those two lines into a single polyline like this. But after this, I actually want to separate this into two lines again, somehow, so that it will be easier to rotate from each vertices. Now, in order to do that, my method is to first of all, for each point on this polypath, if we look at this, I'm going to copy the point number from this point. Actually, maybe I could just use this as it is to rotate. I mean, to transfer the point position from this polypath to this one, to this two lines. Now the primitive number is different from this one and this one, but the point number is the same. You have 4,992 points, and this one also have the same number of points, only the primitive number is different. But since it shares the same point positions, you could copy the point position from this polypath, which has been smoothed out like this, to this original two-line network. which you can do that by using just the single point wrangle. And get the corresponding point position from the second input. And then copy it to the original point position. Like that. And then, as a result, you get two lines being separated but being smoothed out, transferred from this polypath. Okay. Now it's time to actually rotate or twist these geometry from each vertices. Now this is where the vertices stands. Okay. So let's do that. So for each vertices, we would like to get all the connected lines, which is these. And in order to do that, we need what we could do is to use a primitive wrangle. And let's name this twist. Alright, then I'm going to, so let's look at the geometry spreadsheet for each primitive. In this case, each lines. We have a PT num, which tells you which, okay, it's all 0. Something is wrong. Something is wrong. Okay, that has been that hasn't been transferred correctly in this case. Okay, so I thought I have transferred this point number pt1 to each primitive. Okay, this is where it is wrong. It shouldn't be a primitive number, but it should be the name of the number, the lines number that I have created right here. Okay, it's my mistake. Okay, now if you look at each primitive, you get a point number applied to each primitive, and that indicates the vertex point which line is connected to. Okay, now okay, there's one problem here because I am changing the point number at this resample, so I cannot just use the point number as it is, but I guess instead of the point number I should set a point position instead, like pos 1. Okay, like that. That'll do the job, right? Since I want to use this as a center of the rotation. Okay, and also in order to rotate using these points as a center of the rotation, we also need the rotational axis, which in this case is going to be the normal direction of this geometry. So let's also store that to each primitive. And in order to get that point normal, you need to access to that information, to that attribute at pt1. Alright, and let's check. Now you have, for each primitive, you have point normals and point number, in this case a point position. I'm gonna call it pt pos. Okay, I think those two informations is enough in order to twist from each vertices. So let's go back to the twist function and let's get all those informations. First of all, the rotational center point position, which is called as PT pos, and the normal. That was the name, right? PT pos and PT norm, yep. And then use those informations to rotate each point belongs to this primitive, this current primitive. Using these informations. So get all the point numbers out of this primitive. Then for each point, I'm going to apply the rotational transformations. Get the point position. Okay, now in order to apply the rotation to each point, what you need to do first is to subtract the current point positions on the line with the center of the rotation, which is this PT pos. Okay, now you could apply the rotational matrix. Let's create that. Let's create one matrix, rotational matrix, starting from an identity matrix, then rotate that identity matrix with some angle using PT norm as an axis, rotational axis. Then multiply position with this matrix in order to rotate and give this back to with this point rotational center. Now in order to achieve this, you do need to have an angle. You do need to apply some angle, how much you want to twist for each point. And the important thing is that when you do the rotation, the angle for the end point and the starting point should be equal to, especially at the end point, should be equal to 0 in order to stay these two separated lines connected. Okay, so from each vertices, you are controlling the half of the lines. Something like this one. Okay, not able to select somehow. Like this one, this one, this one. Okay, I'm not sure why cannot select. But for each vertices, you're going to select all those half lines which connects it to the vertices. As well for this vertex, you're going to control each lines connected to the vertices. And you see that each lines connected to each vertex, and that the connection of two lines, you don't actually want to move this point to left or right because if you do that, then you lose the connection between this line and this lines. Or if you rotate to the same direction at the same time, then that will be fine. But if you don't do that, then this will be disjointed. So in order to prevent that, in order to prevent the discontinuity, what I'm going to apply as an angle value is some angle derived from trigonometry, like using sine functions or cosine function. Okay, so let's try to do that. Okay, so first thing first, it would be better if we could have an information for each line, for each point, to have a value in between 0 to 1, so that it will be easier to convert it into an angle value. So let's do that somewhere around here. I'm going to call it as f, and f will be I divided by a float, the length of PTS minus 1, and as a result what you get as a value is in between 0 to 1 inside this loop. Okay. And then since now that I have the angle, the value in between 0 to 1 from starting point of the lines to the end point of the line, I want to convert this into an angle value by multiplying f by some angle based value, and I'm gonna use pi for this example because if you use pi with the sine curve or sine functions, what you get as a result is 0 to pi. What you get as a curve is something like this, a mountain-like curve, and you get from 0 to 1 as a value using sine. Okay, and this will be convenient in terms of the angle for our case, because at the end the rotational angle becomes 0, and the middle you get some high value, and the initial value is equal to 0, so it's no rotation. There's no rotation on 0 as well. So as a result you get something like this twisted curve as a rotation. Okay, so that's what I would like to get. Now it might probably work something like this as well, like rotating from like this, like 90 degrees curve from, in this case, half pi to pi. This curve might also work, but let's try with this one first. Okay, so this is going to be the angle from 0 to pi by multiplying 0 to 1 value to pi, and then use this with the angle right here, and finally rotate the matrix and multiply it to the positions. Now I still have some errors here. Where is that? Syntax error, unexpected. Okay, I'm missing I. And I am also missing something here. Rotate. Ambiguous called to function rotate. Candidates are void rotation, float, void rotate matrix int. Okay, is it ambiguous? PT, okay, forgot to say it, PT norm. Okay, rotational, is this still ambiguous call matrix? The angle is float, the matrix is matrix, so I'm not sure why this is still ambiguous. Let's see. Okay, maybe a spell mistake. Alright, so now that I have rotated the point positions, next thing I want to do is to update the actual point positions with this virtual point positions that I've calculated. And let's do that by set point attribute to this point number. So set point attrib 0 pt with this new positions. Okay, have some weird stuff going on here. Let me see. So I have this primitive. Okay, this is where it is wrong. This should be primitive number. Okay, now it seems like I am rotating too much, so I think I need to kind of restrict the angle, how much I should actually rotate. Now, as a okay, actually, I didn't really use the sine wave, so that was one of the problem. Okay, now looks nice, but in this case, I cannot really control how much it should rotate. And the rotational value right now is being used is the value in between 0 to 1. And 1 is somewhere around 90 degrees. So instead of just assuming how much the angle it is, let's try to create some parameter so that you can control the actual rotational value by yourself. Hello everybody, and let's set the angle with degrees, like in between 0 to 180 degrees, and convert this value into the radians and multiply it to the sine value. So multiply radians, something like this. Okay, and if I increase this, now you could see the twisting happens. And I'm controlling each line connected to these vertices, but since the endpoint is not rotated because of this sine wave, sine functions, you can see that the line is being still connected like this. Now I don't really like this pointy edge, so we're gonna merge this later to make it smoother again. But so far it looks okay. This itself looks neat as a pattern. Okay, let's give this as a parameter. Oops, what did I do? For bit linking and bring up this angle value. Okay, now let me think what I need to do next. Now that I have this angle, and I think it also works on that negative direction, so let's set minus 180 to positive 180 and see what happens. So if I set it to negative, you get counterclockwise to rotation. If it positive, clockwise rotation. So if you have two twisting values and merge it together, and one side it is positive, one side is negative. Okay, probably I should multiply -1 to this one. You get a crossed curve like this, which is similar to what we see in here. Okay, looks nice. All right, now I don't need this for now, just need one. Now one thing that I want to try out is changing this range for the angle, just like told you. Like, what if I do from 0.5 pi to pi? So meaning you have a full angle rotations on where the point position is equal to 0. But at the the endpoint still keeps 0 as an angle. So to do that, what you could do is to use fit functions for f, and then goes from pi multiplied by 0.5 to pi, then apply that to the sine functions, and it looks more cleaner in terms of the rotation. You don't have much twisting on the center, seems like, but looks pretty nice. And if I make this back to 0, you get something different. More twisting happens. So this could also be another parameter that I could apply. The angle starting ratio. Okay, this could be interesting. There you go. If it's equal to 1, then there's no rotation, but by applying this ratio, you can control the twistiness of this angleness together with this actual angle. Nice. Yeah, small detail, but might be useful later. Okay, let's bring that value to the controller as well. Alright. Now, now that I have this twisting curve, it's time to make it projected on top of the original geometry, which in this case, a sphere. Now actually, the actual sphere, we don't have an actual sphere, but instead we have this low poly sphere. So what I would like to do is to start from a really high poly sphere, something like that, and then maybe use the remesh to make it really low poly right here, making the target size really big, like 0.4, with smooth iteration turned on. Now you don't really get the nice sphere shape like I used to have from here, but in order to make it procedural for any kind of input geometry, I would go with this. Oops, that was too much. That was too much. Maybe good enough. Not really a regular triangle, but let's go with this and see if this could still work. Or you could just replace it with the low poly sphere as you like. But for myself, let's go with this. Or maybe another way to think of is to, no, let's not make it too complex. I'll just try with this and see if the twisting looks okay. Looks fine to me. Yeah. Okay, looks good. So next thing I would like to do is to smoothen out these edge here, the connection right here. Okay, so in order to do that, should I do it right here, right now, or not sure. Let's try to do it right now. So in order to do that, I do need to connect these separated lines together as a single poly path, I think. Because if you just use smooth to this one, oh, actually it did work. You didn't really need it to connect the polyline together. Okay, so this is nice. So by using the smooth, you are getting rid of this pointy edge here, which is nice. Now this itself looks nice, but what I would like to try out is to project this onto a smoother surface like this one. So let's try this next. So this is going to be the original geometry. So let's call this geo. And let's bring that geo using object merge. Looking for the same name. And somehow project this curve onto this geosphere. Now, the easiest way to project is to just use the minimum projection or minimum distance projection. So let's try that. Just refer to the second geometry, and then project the point position to the minimum point position from the second input. Okay. Now, actually what I really want is not just the point positions, but also would like to get the normal direction which the point has been projected onto. So in those cases you cannot use minimum positions, but you do need to access the UV to the sphere. So in order to access the normal directional value, I'm going to apply a normal point normals before the geo, then go back to this projection, then change this to a function called XYZ distance. And XYZ distance gives you an optional value like the projected primitive as well as projected primitive UV value. Okay, so by using that you can access to a projected point position using prim UV at prim, accessing to the P attribute at primitive with this UV value, but you could also access to any kind of attribute like normal as well using the same function just by changing the attribute name. Okay, now you could replace the point position with this, and you could also apply a normal direction derived from this normal. Oops. Okay, it has to be referring to the second input. Okay, and if I look at the normal direction, you could see the clean normal direction as well. Okay. Now that I have projected this curve onto a surface, next thing I would like to do is to create something similar to this column-like shape. Okay, so you have this kind of bridge going from the center to another center using this, having this kind of arc-like shape. Right, so that's what I would like to get from this point to this point, or this point to another vertex. And you can do that just by applying the height to each of this connected line using maybe another sine wave or something from start to end. Okay, and use it as a height value. So let's try doing that. I'm gonna use another point wrangle, or should I do it using primitive? Yeah, using primitive is easier. So instead of point, I'm going to use the primitive wrangle. And what I'm going to do here is pretty much the same things that I did in twisting. So let's copy some of the part in twist wrangle. So I could get all those informations, PT pause, maybe, not sure if we need this one, so just get the PT pause. Well, just gonna copy everything and just delete the unnecessary stuff. Okay, so I don't think I need PT normal because I already have each point normal positions. I don't need the angle. I do need a point number, and I do need each point positions. And since I'm not rotating, I don't need these operations. I do need these operations in order to update the point positions. Okay. And I actually need the F value, which is in between 0 to 1. I think I have just deleted it. This one. And probably this angle value as well. So let's bring that right here. Alright. So I probably don't need this one. So this will, wait, I do need it actually. Oops. Instead of angle mult, this is going to be the height mult. So, which indicates how much the maximum height of the arc. Let's give parameter height. Okay, so I have this height and angle start ratio. I don't think I need this angle start ratio. In this case, the starting point should be equal to 0 and the end point should be equal to 1. So what I need to do is to start from 0. So the sine with the angle 0 is equal to 0 and the sine, the half pi is equal to 1. So do something like this. Okay, now this should, is in result, will create an arc-like shape for each connected lines to each vertices. And what I want to do now is to, actually this is the height information. What I'm going to do is to apply this height information to move this point position to the normal direction, right? So the normal direction is n at pt. Then you could move this point to the normal direction. Just in case, let's normalize this and multiply by the height value. Okay, and I'm seeing some caches here. Okay, is it moving slightly? It is moving, but not so much. So let's give a range from 0 to 10. Let's see. Okay, now I am seeing some changes, and as you can see, it is creating a bridge-like shape like that. Okay, a bit looks more like a flower. Now I'm kind of wondering, why does it need so much values to move, since this size is equal to 1. Looks a bit weird. Wait a minute. This is the height, right? And this is supposed to be value in between 0 to 1, I thought. It actually doesn't look like so. Let's see the actual value that I get. at each point number with this height that I have just created. What's the value? From 0 to 0.17. Okay, that's pretty small. So okay, so what's wrong with that? I thought this was in between 0 to 1, but it actually doesn't look like so. What if I apply F? Okay, F is in between 0 to 1, so that's correct. That is correct. Okay, so fit 0, 1. So this is 1. This is an angle which is in between 0 to half pi. What if I remove this? I want this to be in between 0 to 1. Is that it? Okay, 0 to 1, that's correct. So if I multiply this result, the sine wave result, with this, oh, okay, why am I using radians? That's the reason. Okay, my bad. So now it looks too big. Let's change the range to 1. Back again. Okay, this looks correct. And I also would like to control this curvature here. Looks like straightly converted from the sine wave. It's okay, it's still okay, but might be better if I could control this curvature with additional parameter. Okay, so in order to do that, one way I could do is to change this f value somehow using something like powered function. And let's give this power functions from 0 to 1 and see how it changes the curvature of the arc. And as you can see, by changing this value slightly smaller than 1, it gives you more straight arc. If it goes more than 1, then gives you a bit more a bowl-like shape on the bottom. Both ways looks fun, looks interesting. All right, I could go either way, like that. Okay, so let's go with 0.5 or something, which I like it. All right, so far so good. And now that I have these curves being created, I can now make this into a mesh-like geometry by first of all connecting all those separated lines together using polypath, and then make this a little bit smoother, because as you can see it's a bit too glitchy, too polyline-ish. So using another resample node to resample, maybe using the same value that I have set here, resolutions. And change this to maybe interpolated curve to make it a bit more smoother. And I do still see some unsmoothness somewhere around here. So maybe I could also apply additional smoothness in between, maybe after projection, or maybe after I have changed the arc height. slightly adding. Okay, well, the problem is it's changing this arc shape, which I don't really like, so let's do it after resampled. Which gives you smoothness on top of the curve, but preserving the endpoint. Nice. Alright. That looks good. Now I am ready to make it as a mesh, something like applying some polywire or pipe shape. Okay, I have a question from Omar Davila. Is it possible to 3D print this? Yes, of course you could do that by creating it as a mesh like this and convert it into a one single mesh, like using VDB or something. Then you could definitely convert it into, you could definitely send it for 3D printing. Apply some radius and apply some normal, and there you go. Pretty nice, isn't it? And changing all those parameters that I've created. You could see several patterns. Like that. Right now and you could also increase like the number of layers, the number of lines as well. Let me first bring all those parameters that I've added to the controller node like these. So okay, height, it's gonna be arc height. Now if you want to have more control over the arc, then there's also a way you could use like ramp parameter, but for now I'm gonna use these power. It's gonna be easier. Alright, what else? I could probably control this thickness as well. Let's bring those thickness. And okay, so far so good. And let's go back to the controller, and if I change the number of lines, looks nice. More lines you have, more fiber it looks like. And I probably want to create an option to be able to create the other side as well, to make a cross structure, something like this one. So let's give that option to somewhere, maybe this one, twisting. So in order to add that additional like angle, in order to add if this is rotating, twisting and clockwise, then just adding additional loop which goes to the negative angle, set it right here, will just do the job. So what I could do here is to just gonna add the for loop. for each number. Then, oops, and let's make this two loops and give a twist, connect it right here, and get the iteration number from the loop, which is always in between 0 to 1 because I only have 2 loops. So what I'm gonna do is to convert this iteration number to be multiplied to this angle value so that it can be used to multiply +1 and -1. So I'm gonna remap this value, which is in between 0 to 1, to -1 or +1 to -1. Then multiply it to this angle multiplication. Okay, as a result, you get the crossed network. Now I think I do still want to have a choice if I want to have a cross network or not. If you just want to have this one side, then all you need to do is to just set this iteration z to 1. And there you get only one side. So let's have that as a parameter. I'm going to use instead of using the slider, I'm going to use something like a operator list. No, not this one. What was it called? I just want to create a context menu. Forgot what it's called. This one, ordered menu. And or actually just using a toggle is fine. Using cross or not. Alright. Now the toggle value will give you value in between 0 to 1. So what I want to do is to first of all paste that value here and add it by 1 so that you get either 1 or 2. So if I click this, you get across lines. If you uncheck this, you just get one side lines. Nice. Alright. What else? Before going into the animation, I would like to have some options to be able to open up this center so that I could have a similar like column-like effect like these. In this case, the point on the center is not connected but have some space like this. I would like to have that effect to this center point. Okay, so in order to do that, I do need to change something somewhere. Let me think. I haven't tried that before, so I need to know where I should do that. I could just probably do it somewhere around here, just offsetting the starting point of the line to somewhere around here, and that might just do the job. Not sure, but I could try. Yeah, but in those cases I shouldn't use fuse because if it's connected I cannot trim out. Or maybe I can just use carve. Let's try. So this will open up the hole like this using some UV value. Let's see what it will do to the result. Hopefully it will do something. And it did. Yeah, it did open the hole. Now, but I do see some problems in here. So I guess I need to fix that, but overall looks nice. It is creating the hole just as I want it. It does have some weird things happening, but so far it is the easiest way to create a hole. Nice, 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 nice. Okay, so let's go back to where I should fix. Maybe after this, in order to make it smoother, might need to fuse it. Yeah. Okay. Well, let's just ignore this for now. And projection is working. Archite is working. Polypaths, resample, smooth, everything is working. And there you go. Okay, looks nice. It's not really circular. That's not really nice. Well, that's not really nice. Yeah, it's not really circular because it's just using UV. Maybe I would like to make it as circular in terms of this whole shape. Oh well. In those cases, what can I do with that? There is a function which is at the groom.h, which is derived with Houdini installation. Let me check where that is. Okay, gotta go to this folder. Then where was it? Inside Houdini, inside Vex, inside SOP, was it? Nope. Inside include, there is a name called groom.h. So let's open this up in the text editor. And there is one function which I could use to trim the curve, which is this one, adjust prim length. So let's try to use this one. Okay, so first thing first, I gotta import this library. It's called groom.h. So include, wait, how do I write it? Groom.h, does it work? I'm not sure if this is the right way to write. Should be fine, similar to this one. Yeah. Okay, then I want to call this functions. So this is the geometry, which is 0. The primitive number is primnum. Current length. Now I don't have the current length, so let's calculate that using measure node. Perimeter. Okay. So get the perimeter and the target length. Now this will be how do I decide the target length? Now since I want to trim out the curve by the circular distance or a sphere distance. This is actually a bit hard to think. Yeah. What's the best way? Because this cannot, I cannot directly use some lengths like the perimeter, the 80% of the perimeter to this target length. It will just create the same effect as carve function. Or the other way. Maybe I gotta flip this curve. Yeah, getting the same thing here. So instead of using the target length to be set at a percentage of this perimeter, I need to know where to cut, where to actually trim based on the position distance from the center. Right. So in order to do that, I have some idea. Yes, I have some idea. Okay, so before going to trim, what I am going to do is to apply some distance value for each point, which is from this point vertex, the triangle vertex. Okay, so that should be from 0 to some distance. Okay, I don't know what's the maximum distance is, but in order to do that, first of all, you get the primitive number from the point, or maybe change this to primitive, that'll be easier, and set point distance. Okay, now I can copy some of the part from the twisting somewhere, like changes the foot somewhere around here. Okay, and then go back to this one. Now this part is okay, this part is okay. I don't really need these. I do need F. Okay. So what I need is the point position, I mean the distance from the center of the triangle, the vertex the triangle vertex to each of the point position. Now the question is, the starting point is applied to this PT pos, right? So I should get that. Then what I'm gonna do is to calculate the distance between this PT pos and positions, and this is going to be linear distance, because what we want to do is to trim with the sphere. Okay, now now that I want to do is to apply this distance into a point as an attribute. So set point attriv dist to each point with this distance value, and let's see how it looks like. So we have this distance value. All right, and now that I have this distance value applied, I'm going to connect this curve trim function and somehow apply this trimming by getting those distance value. So the parameter that I want to have is the trim dist, how much distance I want to trim out. Okay. And in order to find out the best point positions, I am going to use a function in order to find out the corresponding point positions on top of the curve. Now, I am not sure if I can use UV sample. Is this only for a surface? I'm not sure. Let's try to use this to a curve. If that's possible, then that will be great. Okay, so trim curve, or the actually what I need is UV value, I guess, as a result. So currently I don't really have a UV applied to the point, so let's apply some UV value. And how do I do that? How do I do that? Okay. I'm going to use a resample node. Without resampling, I'm just going to just uncheck this maximum segment length so that you are not going to actually resample, but just applying curve U, which is going to create an attribute called curve U in between 0 to 1, which stands as an F value. Alright. Now I think I have all the necessary informations. Let's try to get that corresponding curve U value at this trim distance position by using UV sample. Like that. And now that I have this curve U, and this is supposed to be in between 0 to 1, so hopefully this will trim out the curve circularly. Nope, it didn't. Just give the same result. Okay, so I guess I shouldn't really use the U value after all. It's a bit hard. Harder than I thought. Okay, so instead of curve U, I'm going to get the P, point position. So this is going to be distance position. Then from this distance position, I should be able to get the UV value by using int prim vector UV using closest distance using XYZ distance function with this distance position, giving you the result primitive and UV, and hopefully this UV wait a minute. This UV will give you a value instead of this curve U. Nope, just the same result. Okay. Not sure what else I could do. Well, this didn't work, unfortunately. Let me think why it didn't work. Maybe I shouldn't really multiply it to this parameter after all. But what I needed to do is to calculate the actual distance from the center to this curved length. But how do I do that? How do we do that? I don't think it's possible through vex coding, not sure. Wait, there are one thing. There is one called surface distance. And this one could also use for edges, I think. Distance, when you change the distance metric to accepted, oh yeah, here it is, edge. There you go. Although, in order to use this, you do need to add additional point. Wow, that sounds too much. Eesh. Right. Well, let me check the point position. Okay. What I actually want to do is to go back to the original, like, trim here, the geometry here, and just copy a sphere to that point position. With really small radius, like 0.1. Copy 2 points to those positions on a mesh. Nope, this one. And use this sphere to trim the curve somewhere around here using this sphere. Now it looks simple, but it's not. It's actually not. Well, one of the way I could think of is to just remove the points which is inside the sphere, but that might not create a clean disk hole. So that's the problem. Right. Well, okay, I have one idea. Might not work, but might not be really clean, but let's try. So I have this one. The first thing I'm gonna do is to just delete the point inside this sphere just by getting the calculate the dot product, or maybe in order to make it more simple, just use the group node. I'm gonna give a point group called inside, which is inside the geometry. Alright. And did it give you... Okay, so it gives you the points which is inside this sphere. Now, let's remove those points which is inside. like that. Okay, now it still have a problem. It's more jaggier than before, but the next thing I could do is to get the first point position, the first point of this primitive, then project it to the sphere. Okay, so in this case I'm going to use the primitive, and for each primitive I'm going to get this first point position. First of all, get all the point position of the primitive. And the first point is going to be the point from this array, the first point from this array, and get that point position. And project this point onto a sphere by using minimum position, and update the current point position with this projected point position. Now it doesn't really look like it projected on the sphere. Nope, it's not. How come? How come? Okay, okay. Oh, what I was missing, I shouldn't change the point position of the primitive, but instead I should use set point attrib. Of course, since we are in the primitive wrangle. Alright, now it's a bit more cleaner, and still doesn't really look like a sphere, but actually this is projected on the sphere, so it should be. Okay, so compare it with the one from the carve. It looks much better. The one from the carve, it looks like a hexagon. But this one is more of a disk. So let's get that here and let's look at the final result. Nice. Took a bit too much time for this one, but I think it's an important process. And I don't need this one. No, it's still, I guess it's still okay to use carve, but how do we use it? Now let's have that parameter. In this case, the radius of this sphere. How do I call this? Column radius from 0 to 1. That might be too much. 0 to 0.23. Alright. And if I change that parameter, I can now create a big hole as a column. Nice. Alright. Getting there, I think. Okay, pretty nice. You have a bunch of parameters you can control in order to change those fiber network. Yeah, I think I really like it. you go. Nice. What's happening here? Okay, I think it's due to the cross curve. Okay. I probably, by using a cross curve, there might be some problem using this fuse because it's connecting the merge points. So yeah, maybe without it might be better. Okay, looks nice without it. Alright, what else? I have a question. Why don't you use CarveSop? Just as I show you, by using CarveSop, you get a hexagonal-like shape, which I personally don't like the result. If I use carve, the whole shape looks not really clean. It looks like a hexagonal shape. I mean, doesn't really matter if you don't really care about it, but I do care. I want to make it as a disc shape, so this is a process I just used in order to trim the curve using the sphere. But it doesn't really matter. I mean, the overall result doesn't look much different. Just the process I make it, I prefer. Okay, so now that I have all those parameters in order to control the geometries, I would like to end this by setting up some animation parameters, animation settings, running some kind of a, I don't know, blood-like vein to these fibers, and I'll just finish this. And if you want to send this to a 3D printing, you can just convert it into a VDB, something like VDB from Polygon, and convert this back to a polygon, which will create a single connected polygon, export it to STL, then you'll be able to print it out with your printer of your choice. Something like these. Or maybe if you have like weaving machine or something, maybe you could try weaving this. Well, it's been overlapping, so you might need to create some weaving effect to this one, but that might also be interesting. So in order to create the animation, I am going to apply some simple animation attributes. And in order to create an animation, what I would like to do is to change the thickness of this pipe. So in order to test out, I'm going to reduce the number of lines for testing, and also make this single corner, and let's try it. So what I want to change is these wire radius procedurally using some timeline. So in order to do that, I'm going to procedurally create the P scale for each point on the line, and let's reduce the frame to 30 because I just am going to create the loop animation. Right now, first of all, I am going, in terms of the animation, I think it's better to deal with the points instead of primitive, because points is faster, because you are dealing with all the points simultaneously. So it should be faster than using primitive wrangle. So, but in order to create the animation, you do need a primitive information from the points. So first of all, what I'm gonna do is to get the corresponding primitive number to this point number. And also create the frame-based value by dividing the current frame by the frame end, which will give you a value in between 0 to 1. Alright, then next, let me look at the point and let's see what kind of parameters that I have. Now I think it will be useful if I have a curve view parameter from the resample. So let's enable this curve view. Alright, now going back to this wrangle here, and let's try to create some p-scale value from this frame value. Okay, so what I want to do is to just scale up the p-scale at some point of the curve. Then that scaled up position is moving from starting point to the end point in the loop. Okay, so I want to use 30 frame to loop go travel these thickened pipe from start to the end. So in order to do that, first I am going to create the mountain wave, which indicates the thickness of the p-scale, and probably I could still use the sine curve. So I'm going to convert this f into an angle from pi 0 to pi to 2 pi, meaning 0 to 360 degrees. And then I'm going to convert this into the radius by using this angle with the sine, which gives you a value in between -1 to 1. So I'm going to remap this into a minimum radius to the maximum radius. Now let me bring this to right here. Okay, and for this one I actually want to first set this to 0 to 1. That is because I want to control the steepness of the mountain by adding additional calculation to this by using power function. Okay, just like I did to this bridge arc. Okay, now after this, it is still in between 0 to 1, even if you multiply, even if you use the power function. So use another fit 0, 1 to fit this value in between this minimum radius and maximum radius to be finally used as a p-scale. How's that? Okay, and copy the original radius to the minimum radius, and for the maximum radius I will just set some random value for now, like 0, 3. And for the power, I'm gonna start with 1. See how it looks like. Go back to the, oops. Okay, missing semicolon. Go back to the volley wire, and instead of just using the parameter as it is, I'm going to set the p scale attribute and see how it looks like. Now, doesn't look different. Let me see if the p scale is changing. Nope, it is not. Okay, why is that? That maybe is because... Okay, let me check what the value is for this R. The R is 0.5. Okay, that's wrong. What about the angle? The angle? Nope. Okay, I know why. That is because it is only checking the frame, so... Okay, that's understandable. So what I needed was additional value to this f, which derives from the curve point positional value, which in this case a curve u. Alright, and there is a possibility that this value added together might go over 1, so let's get the remains out of 1. And how's this? Now there are some differences between the curve thickness. If I play it, you can see it is growing from one side to the other. Now the steepness of the mountain is a bit too narrow, so let's give this power node a little bit higher by increasing this range to 0 to 10. And if I make this higher, you have more exaggerated steepness to the mountain, which then looks like blood is running on the wire. Nice. Now I could also add additional randomness where this blood traveling starts by adding some initial random values to this. Maybe I could create the random values here derived from a point number or something. Plus something, some seed value, and add it here. Oops, that was too much. Actually, I shouldn't use the point number, but I should use the primitive number instead, because each primitive has different starting point. Alright, so now this will create a different starting point for this blood traveling thickness. makes it more evil. Let me increase the power to something like 20. Alright, more like a pump. Pumped blood. Okay, like it. Think I like it. And if I increase the number of wires, also make it cross. Okay, that may be too much. Let's stop. Oh well, let's have those parameters applied to this controller as well. So we had minimum radius, so let's change the name this, change to minimum radius. Okay, and also let's bring up maximum radius. Okay, and power, which is the thickness power, or radius power, from 0 to, I don't know, 30 as a maximum. Is that it? I guess. So if you don't need to have like this pumping effect, then you can just set the radius for minimum maximum the same. Just get the normal value. If you make it like that, then you could use this power function to change the gradation of this mountain shape. Now, yeah, in terms of the animation, maybe using just one side of the network looks better. Maybe. It's just my thought. Okay, like it. I like it. Now, I think everything is almost set. It's time to test this out with other geometry rather than sphere to see if it still works. I might need to debug a little bit for other kind of geometries, so let's see if we need to do that. So let's see what kind of geometry that I could test. Test primitive. Let's try with the rubber toy, shall we? And what I would like to do is to okay. The rubber toy itself is pretty detailed in terms of these edges, so it might not work as I expected, but let's see. I might going to scale this up a little bit, like this. And change the shape to the rubber toy. And let's check how it looks like on the remesh. Interesting. Now, let's see the final result. Ooh. Well, some part is failing with the projection, obviously, right here. Maybe that is due to somewhere around here. But overall looks interesting enough. I mean, because these legs are separated geometry, maybe I should convert it into a single geometry, like convert it into BDB first. Then convert back to a polygon. Like that. And see how it goes. Well, not so much. I might need to tweak those height. But this part where the curvature is not that strong looks nice. Wow, that's... yeah. So overall it looks nice, but where the curvature is really strong, it is failing to project, so maybe there are some fixes that I could do still. But it's getting late. Maybe I will just end here. Let me see where is it wrong. Now the the problem is at the remesh It's just removing all the details from the original geometry, so maybe that's the result. That's the reason. So maybe if I set this to just one iteration, might give you a better result in this case. Yeah, a little bit better. Huh, that's cute. No, I don't think it's going to animate in real time because this is going to be really heavy. A bunch of primitives. But let's see. Yeah, well. Anyway. I think I do like the result. It is not based on curly noise. It's just twisting on each vertices. So to review the process, first of all, what I do, create the original, bring the original geometry, remesh to the big triangles, and for each triangles, I'm creating a curve network, something like this. So this is the original triangles. I'm creating these this kind of network on each triangle, right? It's a bit hard to see. And then what I'm doing next is to twist those triangles using somewhere on here at each vertices as a center point, rotational center, like a swirl, right? So it's not really related to any kind of noise, it's just a simple rotation. Then deal with all those smoothness and stuff. Maybe I could have this as a parameter as well, this smoothness. And then project it onto the original geometry. Give some height as as arc, which is controlled here. You can see there's a height. Then just give some polygonal mesh to the result of the curve. And this is the result. Now looks, in this case, looks better in sphere, so I'm just gonna change it to sphere. Okay, so this is the result that I got. And I am right. So yeah, maybe I could also bring up this smoothness to the parameter, which is also changing the shape itself, so I think it's a good idea. This one is just a small smoothness, so let's give this one as a parameter, additional parameter. All right, let's give maximum 100. Okay. So what do you think about these processes? I hope you found something interesting in these. I myself really enjoyed creating these, actually. Ooh, What's happening here? Interesting. I guess that is because of this remesh iteration. Maybe this could also be parameters, or this could also be parameters, so for sure. Let's do that. Let's do that. Okay, well, as always, thanks for all the comments. As always, I'm going to upload the files to the GitHub, and you can freely download the files from the video description page or from the Patreon page of mine. So feel free to use it for any usage. You don't need to set any credit whatsoever. Just play out with the process that I show you today. And maybe if you find it interesting and found it, then give some comments, might be great. Okay. Okay, I guess I have all those necessary parameters in order to control single geometry with all those set up. Oops. So and let's see with other material. I'm just gonna change the matte cap material to something interesting, like this one, or like this one. It's a bit washed out. I guess it's due to the gamma value. Alright, looks nice. Okay, so that's pretty much it. Thanks for watching, and hopefully you get something out of this. Tons of X's again, but I think it's worth it in order to understand the structure and in order to control flexibly. Okay, let's give some final shape and I'll finish this. Gotta make it close. Nice. And give a small smoothness. Tons of numbers of layers. More like a Islamic pattern. Yeah, I really love it. Alright. Well, maybe I still like this. Okay, well, that's it. Thank you very much and good night. As soon as I finish this live stream, I'm going to upload this so that come back to the video description page so that you can download the file, or you can also go to the GitHub repository directly to check all the files that I've been uploading. I have been uploading like hundreds of files in total, so maybe there are some files you might find interesting other than this. Okay. good night, and see you next week. And the next week is going to be the 100th episode, which is something big for me. So hopefully you'll come back. Night.